Hello friends, welcome to my YouTube channel Echo Aftab. In my today's session, we are going to deal with a new concept and that is matrices. So let us go ahead and see what do you mean by matrices. So we shall start with the help of an example. Let us assume that the clothing brand has 4 outlets in different states and in every outlet there are 4 product lines such as jeans, shirts, t-shirts and shoes. So how can we arrange the above information systematically? So the above information we can arrange it such as outlets. So here I assumed it to be Bangalore, Mumbai, Delhi and Dharwad, and these are the 4 products of this particular brand. So in Bangalore there are 120 shirts, jeans 210, 100 t-shirts and shoes are 50. Similarly, the number is there for Mumbai, Delhi and Dharwad. Now, if you look at this particular table, when we look only at the numbers, what we are doing is we are systematically arranging all the products with specific product line which are available in different outlets in different states. So only if you take the number which I have put it in bracket, this becomes our matrix. So when I speak about matrix or matrices, this particular green strip is the row. This is row 1. So what do you mean by rows in matrix? Numbers that are there in the horizontal line are called as rows. So this is our row 1. Next is row 2, then row 3, then row 4. So in this particular matrix, we are having 4 rows. Similarly, if you go on for vertical line, you can see this particular strip becomes our column 1. Numbers in a vertical line are called as columns. This is column 2, this is column 3 and this is column 4. So there are 4 columns and 4 rows in this particular matrix. Matrices is in plural form. Singular form it is called as matrix. So matrices is a plural form of matrix. Then what do you mean by matrix? Matrix is a rectangular array. So here it is a rectangular systematic arrangement of numbers. It can be 1, 2, 3, 4 or parameters. It can be beta 1, beta 2, gamma, alpha, etc. or variables. It can be x, y, z, each of which has a carefully ordered place within the matrix. The numbers are referred to as elements of the matrix. So this 120 which is there in the matrix, this is an element. So this way all the different numbers are called as elements of the matrix. The number of rows R and column C define the dimensions of the matrix. So here there are totally how many rows? There are 4 rows and there are 4 columns. So the dimension of the matrix is called 4 by 4. So the rows and the number of columns R by C or 4 by 4. So the dimension of this particular matrix is 4 by 4. Now, having understood what is the meaning of matrix, let us see a general notation for matrix. So here in this particular row, I have shown you the elements as A11, A12 up till A1n. So this one A11, what is this telling us? This number is telling us, or this particular element is telling us that number which is in row 1, I'm sorry, that number which is there in row 1 and column 1, first row and first column, that is what is 1 1. So it goes up. So this is our first row and column 2, column 3, 4, 5, 6, 7, 8, it goes up till n columns. Similarly, this is the second row, row 2, and it goes up till n columns. Then you can see the columns goes on and on and on, and it goes up till m columns. So this m and this n, so the last element is the infinite element where we are having m rows and n columns. So this particular thing, if you put it in a bracket, we get the notations for matrix. Example, let us see one simple example. Now, why and where matrices we make use of it? 2x plus 6y is equal to 22. So, this is 5x plus y is equal to 53. Now, this particular thing, if you want to find out what is the total number of x units, or what is the value of x, or what is the value of y in this particular function. So, this you can do it, as I told you in the previous slide, by simultaneous equations. Or there is one more way where else we can find out what is x and what is y. So, what I will do is, I will write the coefficients first. 2, 6, 5, 1. This is 1y. So, this I will write it in a form of matrix. Then there are two variables, x and y. This also I will write it as a vector matrix is equal to 22 and 53. So, here friends, these 2, 6, 5, 1, this becomes our coefficient matrix. This x and y is our variable matrix, and this column, vector column 22 and 53, becomes our constant matrix. And here, if I call our coefficient matrix as A, and if I name the variable matrix as X and the constant matrix as Z, then there is a formula, that is A into X is equal to Z. A into X is equal to Z. So, if this particular coefficient matrix is A and this particular variable matrix I call it as X, then A into X is equal to Z. Or I can say X is equal to A inverse Z. So, this is the way we try to find out what is the value of the variables x and y. So, this is one way. Or else I can also say, I will give you another example. If I say there is an function 7p1 plus 2p2 is equal to 60, and minus p1 plus 8p2 is equal to 78. Now, if this is price of one commodity and price of second commodity, and this is with regard to two different markets, in such a situation, again I will write the coefficients 7, that is this number, plus 2 here comes, and here we are having minus 1 and 8. So this particular matrix is our coefficient matrix. Then comes the two variables P1 and P2. So this is our variable matrix, and the constants is 60, 78. So this is our constant matrix. So if I name coefficient matrix as x, a, variable matrix as x, and constant matrix as z, it means a into x is equal to z, that is a into x is equal to z, or x is equal to a inverse into z. So friends, right now I will not tell you how to solve this thing. We will keep it at parking. What is A inverse, what is transpose, all those things later on we will understand. This particular example only meant to be that how the linear equations, how the linear equations we are transforming them in the form of matrix, and how this matrix will help us to find the values of the variables. So these values of the variables, right now it seems to be very easy that we can make use of simultaneous equations and we can solve it. But just imagine friends, if we are having many equations and this list goes on and on and on, and if these entries are, we are having around 15-20 equations, then with the help of simultaneous equation we cannot do it. But definitely with the help of matrices and determinants we can find out the value of the variables. So here this is the way we make use of matrix in understanding economics. It may be with regard to demand function, or it may be with regard to budget set. There are so many ways. It may be with regard to national income. We are having, for all these things there are certain equations. These equations are in the linear form, and we can make use of matrices to solve for this linear equations. Going ahead, there are different types of matrix. So very quickly we will go through the different types of matrix. First one is called as row matrix. The name itself tells what is this. So it's a matrix which is having one row. A row matrix is having only one row but any number of columns. So here if I say A is equal to 1, 2, 4, 5, so this is a row is 1, and this is column 1, column 2, column 3, column 4. So this becomes 1 by 4 matrix. So here how we denote it, A is equal to Aij 1 by n matrix. Now what is this Aij? Aij refers to entry in row I and column j. Ith row, jth column entry is what is Aij, and this is 1 by n is telling us that row by column, one row and n number of columns. So this is 1, 2, 3, 4. If this goes on, this become n number of columns. So this is row matrix. Next is column matrix. As the name says, here there is going to be one column and n number of rows. A matrix having only one column is called as column matrix. So this is one column and rows are row 1, row 2, row 3, row 4 and so on. So here also you can see it is m by 1 because the rows are m number and there is only one column. Next one is rectangular matrix. The name itself tells any matrix in the rectangular form, it may be vertical rectangular or it can be horizontal rectangular. So this is what is rectangular matrix. Is formed by different number of rows and columns. Here rows and columns. Here if the rows are more than columns or if the rows are less than columns, then it can become vertical matrix or horizontal matrix. So you can see here we are having column 1, column 2, row 1, row 2, row 3 and row 4. So rows are more than column. So in this situation we call it as rectangular matrix, or else it is also called as vertical matrix. If you see this thing, here we are having row 1 and row 2 and column 1, column 2, column 3, column 4. So here what is happening? Rows are less than columns. So this becomes our horizontal matrix. So in both the examples you can see the number of rows and number of columns are different. So when the number of rows is more, it becomes vertical matrix, or if the rows are less than columns, it becomes horizontal matrix. Then comes square matrix. The name itself says if the rows are equal to columns, when the rows and columns are equal, then it is a square matrix. A square matrix is formed by the same number of rows and columns. So here we can see column 1, column 2, column 3, row 1, row 2, row 3. So this is 3 by 3 matrix. So the dimension of this matrix is 3 by 3, and this type of matrix are called as a square matrix. It can be 3 by 3, 2 by 2, 4 by 4, 6 by 6, 10 by 10. So if the rows are equal to the columns, then we call such matrix as square matrix. So here friends, M is equal to N. The number of rows is equal to the number of columns. Then comes zero matrix. So in the name itself it is there. What do you mean by that? So a matrix where all the elements are 0 is called as zero matrix. That is as simple as this. So if all the elements of a matrix are 0, it is called as zero matrix. So here every element in every row and column combination is giving us 0. Such a matrix is called as zero matrix. Identity matrix. When we speak about identity matrix, here the identity matrix is a square matrix, first point, is a diagonal matrix, second point, in which all entries on the diagonal are equal to 1 and the rest of the elements are equal to 0. This is what is identity matrix. So when in a matrix, if this is a matrix, so what is it telling? It is a square. So square matlab here it has become 3 by 3, rows are equal to column, and here this is a diagonal. So this diagonal, what they are telling, every element in the diagonal is going to be 1 and rest all others are going to be 0. If such is the matrix, it is called as identity matrix. So here you can see diagonal we are having 1 and all other elements are 0. So this is a 3 by 3 matrix. As other elements are 0 and only diagonal is having value, it is a square matrix because it is 3 by 3. Because only diagonal has a value, it is a diagonal matrix, and because that diagonal value is 1, it is also an identity matrix. So we understood 3 types of matrix in this single example. If this value is not 1, but if it is anything else other than 1, so in the diagonal, if all the values, that is a row and column I and j, a, I and j is equal to 1, then it is called as identity matrix. Scalar matrix. The scalar matrix is a square diagonal matrix in which all the entries on the main diagonal are same and the rest of the elements are 0. So, here if it is 1 1 1, if it is 1 in the diagonal, it becomes identity matrix, but if it is other than 1, it can be 2, it can be, as in the example, 3, it can be 10, it can be anything. So, then it becomes a scalar matrix. Suppose B is equal to 5 0 0 0 5 0 0 0 5. So, the elements in diagonal is 5. So, here it is 5, here it is 3. So, both these matrices are scalar matrix, and what is their nature? It is a square matrix as well as an diagonal matrix. Now, you understood what is diagonal matrix. So, in diagonal matrix, all the elements above and below the diagonals are 0. So, here 1 6 5. So, here you can see in diagonal the elements are not the same. So, it is just a diagonal matrix. If the elements are same but not 1, it is scalar matrix. If all the elements in the diagonal are 1, it is identity matrix, and as all the rows are equal to columns, it is called as square matrix. So, in square matrix, n is equal to m. In diagonal matrix, in the diagonal we are having elements and all other elements are 0 apart from diagonal. In a scalar matrix, the elements are same. In identity matrix, the elements are 1. So, this is the difference between square matrix, diagonal matrix, scalar matrix and identity matrix. So, diagonal matrix is a square matrix, scalar matrix is also a square matrix, identity matrix is also a square matrix. Scalar matrix is also a diagonal matrix, identity matrix is also a diagonal matrix. It becomes scalar because the numbers are same. It becomes identity if the diagonal elements are equal to 1. Now, you can see it is like a combination of upper rectangular and lower triangular matrix. So, here on the upper triangle there are 0, on lower triangle also there are the elements are 0. Now, through this we can get two different types of matrix further. So, here you can see A is diagonally we are having 165 and below 165 we are having all the elements 0, and in the next matrix, let us say I will name it as B. B diagonal is 165 but all the above elements are 0, and if this thing happens, we call it as upper triangular matrix. This is upper triangular matrix and this is lower triangular matrix. Now, what do you mean by upper triangular? In the upper triangle we get the elements. So, here you can see 1 3 6 6 9 5. So, in the lower triangle the elements are 0. Here in the upper triangle the elements are 0, in lower triangles we will get certain values. So, this type of matrix are called as upper triangular. All the elements below the diagonal are 0, that is upper triangular. All the elements above the diagonal are 0, that is lower triangular matrix. So, these are the various different types of matrix at elementary level for us to know with regard to matrices. Now, we shall see matrix operations. When you speak about matrix operations mainly involve three algebraic operations. They are addition of matrices, subtraction of matrices and multiplication of matrices. Friends, we don't make use of division of matrices because that particular operation we do it by inversing the matrix. So that later on in the next sessions we will understand. As of now, remember, we are making use of addition, subtraction and multiplication of matrices. So what do you mean by addition and subtraction of matrices? Addition of matrices means A matrix A plus matrix B, or subtraction of matrix means A matrix minus B matrix. And here one very important condition is that the matrices should be of equal dimension. If you want to add or subtract two different matrices, then the number of rows should be equal to the number of columns. Rows and columns should be equal to each other. So each element of one matrix is added or subtracted from corresponding element of the other matrix. Let us see. I'll just show you one simple example with regard to this. So I'll take a matrix A is equal to, let me say, 8, 9, 3, 6. So what is the dimension? The dimension is 2 by 2. Similarly, B is equal to, let me say, 2, 3, 1, 4. So these are the two matrices and both of these matrices are having the same dimension. Now if I want to add up this matrix, what I will do? A plus B is equal to, I will add every corresponding elements of both the matrix. So it will be 8 plus 2, 9 plus 3, 3 plus 1, 6 plus 4. So 8 plus 2, 9 plus 3, 3 plus 1 and 6 plus 4. So what will I get is 8 plus 2, 10, 9 plus 3, 12, 3 plus 1, 4, 6 plus 4, 10. So this is the value that I get after adding two matrix of the same dimension. So even here this is also a 2 by 2 matrix. Similarly, if I want to make it A minus B, then what I will do is 8 minus 2, 9 minus 3, 3 minus 1 and 6 minus 4. So this will be 8 minus 2 is 6, 9 minus 3 is 6, 3 minus 1 is 2, 6 minus 4 is 2. So this is the matrix that I get, and this is also 2 by 2 matrix. So this is as simple as adding the elements in every row with the elements in every row of the other matrix. So here the basic condition is that the number of rows should be equal to the number of columns, that is n should be equal to m. Next is scalar multiplication. So what do you mean by scalar? In matrix algebra, if we have a simple number such as 10 or minus 3 or 0.7, these numbers are called as scalar. A single number is called as scalar in matrix algebra. So multiplication of a matrix by a number, or you can say by a scalar, involves multiplication of every element of the matrix by the number. So if K is scalar and A is a matrix, then multiplying the scalar by the matrix will give us this particular matrix. So K into A is equal to multiply each and every element of A matrix with the scalar value. They say friends, I'll just show you one more example with regard to this. If K is equal to 8 and matrix A is equal to 5, 1, 2, 3, then K into A is equal to multiplying 8 with all the elements in the matrix A. So this will give us 40, 8, 16, 24. So this is how we go on for scalar multiplication of the matrix. Vector multiplication. Now the things are going to be more interesting. If a matrix has only one row or only one column, it is called a vector. So what do you mean by vector? If a matrix is having only one column or it is having only one row, it is called as vector. It can be a row vector or it can be a column vector. Multiplication of a row vector by a vector B requires a precondition that each vector have precisely the same number of elements. The product of row column multiplication will be thus a scalar. See the points over here. Multiplication of row vector A by a column vector B requires each vector to have same number of elements, and when you multiply it, you are going to get only one value. You are not going to get rows or columns, you are going to get a scalar value. Let us see. If this is a row vector and if this is a column vector, when you multiply these things together, what will you get? So see here, A multiplied by B. So 1 multiplied by 2, 1 multiplied by 2 plus 2 multiplied by 3, 2 multiplied by 3, 4 multiplied by 5 plus 4 multiplied by 5, 5 multiplied by 4 plus 5 multiplied by 4. So this thing will be 2 ones are 2, 2 threes are 6, 4 5s are 20, 5 4s are 20. So it's going to give us 20 plus 20 40, 46, 47, 48. So multiplying a row vector with a column vector is giving us a scalar. What do you mean by scalar? It is one number. This is what is vector multiplication, row vector and column vector. If you multiply, you get a scalar value. Now coming to multiplication of matrices. Multiplication of two matrices with dimensions R into C1 and R into C2 requires that the matrices be conformable. Now what is this? So what it is telling us, the rows and columns in 1 should be equal to the rows and columns in 2, or you can say C1 should be equal to R2. Now what is this? For this friends, I'll try to show you how it can be done. So here I'll take an example. Here we are making use of the word conformable. So here the number of columns in 1 should be equal to the number of rows in 2. Number of columns in 1, that is called as lead matrix. First matrix is called as lead matrix, and number of rows in 2, the second matrix is called as lag matrix. So lead matrix columns should be equal to lag matrix rows. How it will be done? For that I'll take a simple example. Let us say I want to show what do you mean by conformability. So if I say A is equal to 726 548 319, this matrix, if I want to multiply with matrix B, matrix C, 11 4 3. So first friends, we have to see what is the dimension. This is 3 by 3 matrix and this is 3 by 1 matrix. I hope it is clear. See here, column 1, column 2, column 3. This is row 1, row 2, row 3. This is column 1, row 1, row 2, row 3. So here this matrix is having 3 rows and 3 columns, and this matrix is having 3 by 1. So here you can see what is happening. This is a 3 by 3 dimension matrix. Is it equal to this particular dimension 3 by 1? Can we go on for multiplying this thing? So if we are able to multiply this thing, how can we prove that we are able to multiply? The thing is here. So we need to know the conformability. We need to confirm it. So this conformability is possible when you look at this thing. So this 3 is equal to this 3. So yes, we can go on for multiplying the matrix, and the new matrix that we will be getting is of this particular dimension, 3 by 1 dimension. Shall we see, is it possible to multiply it? Yes. So matrix A multiplied by matrix C, we can write it like this. So remember friends, all the elements of this column should be multiplied by this particular row. So R1 should be multiplied with C1. So 7 into 11, 7 multiplied by 11 plus 2 multiplied by 4 plus 6 multiplied by 3. Similarly, the next row, 5 multiplied by 11 plus 4 multiplied by 4 plus 8 multiplied by 3. And similarly, the third row, 3 multiplied by 11 plus 1 multiplied by 4 plus 9 multiplied by 3. So you can see here we are getting AC is equal to 7 into 11, 77 plus 8 plus 18, 55 plus 16 plus 24, 33 plus 4 plus 27. And when I add up this thing, what I get is AC is equal to 77 plus 18 plus 8, 103, 55 plus 16 plus 24, 95, 33 plus 4 plus 27 is 64. So this is the final product we get, and this is of 3 by 1. There are 3 rows and 1 column. So how was it possible for us to get this value? Because we had to first confirm whether this particular matrix and this particular matrix, matrix A and matrix C, can be multiplied, and knowing whether it can be multiplied or not is called as confirmability. And how to confirm it? This is the way: write the dimensions of matrix A and the dimensions of matrix C, and if this particular number, the columns, and here the rows, if they are equal to each other, then the conformity condition is set. If I say for example, A is, I'll take the same above thing, 7 2 6 5 4 8 3 1 9, and C is equal to, sorry, and here now I'll take B. B is equal to 6 2 5 0. So here this is a matrix having 3 by 3 dimension, and this is a matrix having 2 by 2 dimension. So now we'll check the conformability. So 3 by 3, is it equal to 2 by 2? So if you look at this thing, 3 and 2, so here this 3 and 2 is not equal to each other, and because of that we can say matrix A cannot be multiplied by B, because it is not passing the conformability test. This is what is conformability of matrices. Having understood this, let us see one simple example where we are multiplying two matrices with the same dimension. So let us say A is equal to 1 2 3 4 and B is equal to 3 2 4 8. So this is 2 by 2 dimension, and even this is 2 by 2 dimensions. So now if you want to multiply matrix A with B, what do we do? 1 into 3 plus 2 into 4 then comes 3 into 3 plus 3 into 4. Next is 2 into 3, 4 into 8, sorry, 2 into 3, 4 into 4, 4 into 4, 2 into 2 plus 4 into 8. Once we do this, we get 3 plus 8, 9 plus 12, 6 plus 16, 4 plus 32. So this will be 8, 9, 10, 11, 22, 21, 36. So this is the value of A multiplied by, and this is also a 2 by 2 matrix. So in the case of conformability, 2 by 2 is equal to 2 by 2. So this is telling us, yes, we can multiply the two matrices A and B, and the dimension is 2 by 2. So with this, friends, we come to end of the basics of matrices. In my next class, we shall see about certain laws of matrices, properties of matrices, associative property, cumulative property, etc. So till then, friends, thanks for being with me and for watching Understanding Economics with Professor Aftab. Till my next video, take care of yourself, stay happy, stay blessed. Tata, bye bye.